Hello students, welcome to the classroom point. In our today's class, we shall discuss the N factor. N factor is one of the important concepts in the chemistry. It helps us in solving the questions of the redox reactions as well as the titration questions. So we shall see the definition and different type of the examples and their uses and applications by taking some questions also. Let's begin the class now. Let's see the definition of N factor. N factor. So I shall write down this one as N suffix F. The definition of N factor is, it is the charge exchanged or transferred per mole of substance. So here we have to consider only 1 mole of the substance every time. Even in the balanced chemical equation, more than 1 moles are involved. That number of moles we should not take. N factor is always calculated for only 1 mole of the molecule. Now let's see, N factor can be applied to the atoms, molecules, reducing agents, oxidizing agents, salts, acids and bases. So different categories, differently we shall define this N factor. We shall begin with the ions, simple ions. For ions, it is the number of moles of electrons either lost or gained by 1 mole of ions. So let us take the example. So here electrons may be lost or may be gained. Example is sodium converted into the Na plus electron. Here 1 mole of electrons are lost, so that N factor is equals to 1. Let us take the magnesium, Mg2 plus. Magnesium lost 2 electrons, so that N factor is equals to 2. Similarly, imagine aluminum, Al3 plus, 3 electrons are lost, so N factor is equals to 3. Now let us take the chlorine. It gained 1 electron and converted the Cl minus ion. In this case, it gained only 1 mole of electrons, so that N factor equals to 1. Oxygen, if it gains 2 electrons to convert into the oxide ion, N factor is equals to 2. And nitrogen, by gaining 3 electrons to form the nitride ion, N factor is equals to 3. Whatever the number of moles of electrons either lost or gained by 1 mole of atom is called as its N factor. Now let us see for the salts. So in case of the salts, it is the sum of positive charge of all cations or negative charge of all anions. So we have to take either cations, positive charges, or anions, negative charges. Because if cations are formed by the loss of electrons, so the same number of electrons are gained by the anions. That's why N factor we have to calculate either in terms of the cations or in terms of the anions. Both we should not consider it. Either any one of them we have to consider it. So let us take here example Sodium chloride dissociates to produce Na plus and Cl minus ions. So here N factor, positive charge only one is there or negative charge only one is there. Sign convention not necessary to, means some symbol of the sign convention not necessary to consider it. Only the numerical value we have to consider. So N factor is equals to 1. And take the magnesium chloride MgCl2. It gives Mg2 plus 2 Cl minus ions. So N factor is equals to 2. Next one, AlCl3 dissociates to give Al3 plus ions and 3 Cl minus ions. N factor is equals to 3. So in this case, we have taken the simple salts. Let us take the double salts. KCl, MgCl2, 6H2O, carnallite. So if it dissociates, it will produce K plus ions, Cl minus ions, Mg2 plus ions, and 2 Cl minus ions. What is a covalent molecule here which will not dissociate? So here you have to consider the sum of the positive charges. So how many positive charges are there here? 1 positive charge for K plus ion and 2 positive charges for the magnesium, and together it is 3. Or else if you take the chlorines, there are 3 chlorides, each is with -1 charge, so that total value is also equals there also 3. So in this case, N factor is equals to 3. Next, potassium sulfate, aluminum sulfate. If it dissociates, that is potash alum, 24H2 is present. So here it is 2 K plus ions plus 2 Al3 plus ions plus sulfate ions, totally 4 are there. 4 sulfate ions. So here total positive charges, 2 into 3, 6 positive charges, plus 2, 8 positive charges, or else 4 into 2, total equals to 8. So N factor is equals to 8 in this case. Next, ferrous sulfate, ammonium sulfate, 6H2O. It dissociates into Fe2 plus ion, 2 NH4 plus ions, here one, totally 2 sulfate ions. So total positive charges, here 2 plus 2, 4, or else 2 into 2 equals to 4. So total N factor is equals to 4. So N factor in the case of these salts can be calculated by simply atomicity. Atomicity means number of same type of ions here into charge present on the ion. For example, here sulfate is there. 2 sulfates are there. Number of ions 2 into charge on every ion equals to 2. So 2 into 2 equals to 4. So like this we can calculate the N factor for the salts. Now let us see the N factor for acids. So here we said the charge exchanged or charge transferred. Charge can be transferred in different forms, either in the form of the H plus ions or in the form of the electrons or in the form of the OH minus ions. Depending on the type of the molecules we select, we apply the concept. So here acids lose H plus ions. So the number of moles of H plus ions lost by 1 mole of acid is called its N factor, or it is also known as the basicity of the acid. But all protonic acids may not present. Then we have to consider the Lewis acids also. In the case of the Lewis acids, the number of moles of pairs of electrons accepted by 1 mole of acid is called its N factor or basicity. So let us take some examples here. HCl dissociates into H plus Cl minus ions. So this is giving only one H plus ion, so that its N factor is equals to 1. And here H2SO4 dissociates to give 2 H plus ions and SO4 2 minus ion, so that N factor is equals to 2. Let us take H3PO4 dissociates to give the 3 H plus ions and PO4 3 minus ion, so that N factor is equals to 3. You must remember that N factor is not the constant value. For example, let us take both of these. H2SO4 not necessary to release 2 H plus ions in the reaction. Depends on the type of the condition of the reaction. If it releases only 1 H plus ion, still it retains 1 H plus ion with it. Then it is releasing the since 1 H plus ion, then its N factor is equals to 1. And similarly, H3PO4 is there. H3PO4 can release the H plus ions in a sequential manner. If it releases 1 H plus ion and maintains the 2 H plus ions with it, then N factor is equals to 1. Or else you can write down the same H3PO4, if it releases 2 H plus ions plus HPO4 2 minus ion, in such cases N factor is equals to 2. So the acids which release only 1 H plus ion, they are called the monobasic acids. Which are releasing the 2 H plus ions are called the dibasic acids. And this is called the tribasic acid. Let us take another example. H3PO3 is there. Maximum it can release only 2 H plus ion, and it is HPO3 2 minus ions, so that N factor is equals to 2. So the number of H plus ions released by an acid depends on its structure. Let us see some of the molecule structures and we shall come to the conclusion there. So if you take the orthophosphoric acid, P double bond O, OH, OH and OH. It is H3PO4, also known as the orthophosphoric acid. And P double bond O, H, OH, OH. It is H3PO3 phosphorus acid. So how many number of H plus ions can be released by an acid depends on how many number of H plus ions in the oxo acid are connected to the oxygen. The number of H plus ions directly connected to the oxygen are the H plus ions which can be released by the acid. Here this molecule is connected, in this molecule 3 hydrogens are connected to the 3 oxygen atoms, so that it can release either 1 or 2 or 3 all the H plus ions, so that its N factor may be 1, 2 or 3. In this case, it is having only 2 hydrogen atoms connected to the oxygen. That's why it is able to release only 2 H plus ions. That 2 H plus ions it may release in the single step or in the stepwise manner. If it releases only 1 H plus ion, N factor is equals to 1. If it releases both H plus ion, then N factor is equals to 2. But it cannot release this H plus ion because this H plus ion is not connected to the oxygen but connected directly to the phosphorus atom. So the hydrogens which are directly connected to the oxygen in the oxo acids are called the replaceable hydrogens. So the N factor of an acid depends on the how many number of replaceable H plus ions are present. Similarly, let us take the example number 8. if you see this molecule, acetic acid, we should not write down the 4H plus ions here. We can write down this molecule as CH3, COO minus plus H plus. So its N factor is always equals to only 1 because it can release only one H plus. And let us see its structure also. In this structure, 3 hydrogens are connected to the carbon. Only one hydrogen atom is connected to the oxygen. That's the reason why replaceable H plus ions are only 1. Let us take the another one. Oxalic acid, COOH and COOH. It dissociates to give the COO minus and COO minus plus 2H plus ions. So N factor is equals to 2. Let us take some other conditions also. Other molecules. H3BO3 is there. Orthoboric acid. So this orthoboric acid is not a protonic acid. Means it cannot release even H plus ions. In this case, very interesting thing is, it is having 3 hydrogens connected to the oxygen. So we can call actually this one as a replaceable H plus ions, but this molecule cannot release any H plus ions because it is an electron deficient molecule. Still it is ready to accept the pair of electrons from the other substances. So orthoboric acid is not the protonic acid. It cannot release any H plus ions, but after reaction with the water, it forms the complex ion plus releases H plus ion. So it acts as protonic acid only after reaction with the water. Actually, it is not a protonic acid. So we can write down that not a protonic acid. But it is a Lewis acid. It always ready to accept a pair of electrons from the other substances. So these are the some examples regarding the acidic nature, means for acids and factor calculations. Now let us see for the base. In case of the base, the charge may be transferred in terms of the loss of OH minus ions or in terms of the donation of the pair of electrons. So here the number of moles of OH minus ions lost by 1 mole of base is called its N factor. In case of the bases, the N factor is also known as the acidity of the acid. So it has one more definition. The number of moles of pairs of electrons donated by one mole of base is called its basicity or N factor. So let us see some calculations, some examples here. If you take NaOH, it dissociates to produce 1 OH minus ion, so its N factor is equals to 1. And consider the magnesium hydroxide. So it is Mg2 plus 2 OH minus ions, so N factor is equals to 2. Similarly, let us consider the aluminum hydroxide. So that Al3 plus 3 OH minus ions and N factor is equals to 3. Now here orthoboric acid we have taken here. So you cannot, some people represent this molecule like this. BOH taken thrice. So you should not misunderstand this one as a base. Actually, it is an acid. Let us take some more examples. If you take NH3, ammonia, it cannot release any OH minus ions, but still it can react with the 1 H plus ion by donating one of its pair of electrons, so that forming ammonium ion, so that in fact is equals to 1. Now let us take the hydrogen molecule NH2, NH2. It is called the hydrogen. So in case of hydrogen, there are two nitrogens having each one a pair of electron. So if you subject this molecule with 1 H plus ion, it forms NH3 plus and NH2. It can react only with 1 H plus ion but not with 2 H plus ions. So N factor is equals to only 1. What happens if you subject this one with the 2 H plus ions and expecting the both nitrogens neutralized by the H plus ions and expecting this one, it is very unstable. The formation of this particular ion is difficult because two positive charges on the adjacent atoms makes the ion difficult to exist. Hence, it's in fact always equals to 1. Now let us see NH2, CH2, CH2, NH2. Ethylene diamine. So this can react with the 2 H plus ions because these two nitrogens are away from each other, so that by adding 2 H plus ions, you can convert this molecule into the NH3 plus, CH2, CH2, NH3 plus, so that the N factor value is equals to 2. So like this, for bases we can calculate the N factor values. Let us try to see some small questions and how the N factor value depends here. So here I shall take example H2SO4 reacts with 1 mole of NaOH giving NaHSO4 plus H2O, and similarly H2SO4 react with 2 moles of NaOH giving Na2SO4 and 2H2O. So in these two conditions, the N factor of the acid varies. In the first condition, H2SO4 is donating only 1 H plus ion, releasing only 1 H plus ion, and combining with the only 1 OH minus ion. That's why in the salt still it is having the 1 H plus ion. That's why its N factor value in this particular reaction is equals to 1. And in the second reaction, H2SO4 releases all of its 2H plus ions, and those 2H plus ions completely mixed with the 2OH minus ions coming from the 2 moles of NaOH. So complete neutralization had happened here. So in this case, N factor is equals to 2. So N factor value is not constant. It varies from the reaction to reaction and molecule to the molecule. Now, let us see the calculation of N factor for the redox reactions. Oxidizing and reducing agents. How to calculate the N factor for the oxidizing agents as well as the reducing agents. So now let us see what is oxidation. Small definitions, we shall discuss it. Complete definition of the oxidation and all these we are not discussing, that shall be discussed in the redox reactions chapter. So oxidation means simple term is loss of electrons is called as oxidation. Reduction, gain of electrons is called as the reduction. Since an atom is losing the electrons, oxidation number increases. Oxidation number increases. Here, since they are gaining the electrons, oxidation number decreases. Oxidizing agent. Oxidizing agent means which oxidizes the other substances. To oxidize other substances, it has to accept the electrons from those substances. That's why oxidizing agent oxidation number always decreases. The one which gets reduced is called the oxidizing agent, and reducing agent. Reducing agent means it has to reduce other substances. So, reduction means gaining of electrons. So they are gaining electrons means this is giving the electrons for them. So the one which is reducing other substances by giving its electrons is called the reducing agent, and since it is losing electrons, its oxidation number increases. So the one whose oxidation number increases is called reducing agent. So we shall take some examples, some molecules, oxidizing agents, reducing agents, and some act as both oxidizing agent as well as the reducing agents. So here, first of all, n-factor definition for the oxidizing agents and reducing agents. As I said now, oxidation is the loss of electrons, reduction is the gain of electrons. So completely in this process, electrons are exchanged between the oxidizing agents and reducing agents. That's why n-factor can be defined as the number of moles of electrons lost or gained by a mole of substance is called its n-factor. So which molecules we are going to discuss here? So we are going to discuss about the potassium permanganate KMnO4. Second one is K2Cr2O7 potassium dichromate. Third one is H2O2 hydrogen peroxide. Fourth one is Na2S2O3 hypo sodium thiosulfate. First two act as only oxidizing agents. Hydrogen peroxide can act as both oxidizing and reducing agent. And this is acting as the reducing agent. So we shall take one by one these molecules. So first of all, KMnO4. It is known as the potassium permanganate. Potassium permanganate. So this KMnO4 dissociates to give the K plus and MnO4 minus. This is called as the permanganate ion. Similarly, we should not get confused from this one, K2MnO4. This is called the potassium manganate. So it dissociates to give the 2 K plus ions and MnO4 2 minus ion. So this is called the manganate ion. It is called the manganate ion. Now let us see the potassium permanganate oxidizing nature in acidic medium. We have only acidic medium calculation. Some neutral 3 are there, but we shall go mainly with the acidic medium calculations which are commonly asked in the examinations. So in acidic medium, or else we shall see first of all three categories. MnO4 minus, in acidic medium, neutral or weak alkaline medium. This is strong, basic or alkaline medium. So let us take the three different cases here. Here manganese oxidation state is +7. It changes to the Mn2 plus. And in the neutral medium, it changes to the MnO2. In strong alkaline medium, it changes to the MnO4 2 minus. You should remember that potassium permanganate and potassium manganate are interconvertible. See here, potassium permanganate is converting to the potassium manganate, means permanganate ion is converting to the manganate ion if you add the basic medium. If you add the acidic medium, this manganate ion start converting back into the permanganate ion. So in acidic medium, it exists in the form of the permanganate ion. In alkaline medium, it always exists in the form of the manganate ion. Now, let us see the change of the electrons here. Manganese oxidation state is +7. Here manganese oxidation state in acidic medium is +2. Means here manganese accepted the 5 electrons. That's why out of 7 positive charges, 5 positive charges are neutralized. Still 2 positive charges are present. So how many number of electrons it gained? 5 electrons. That's why its N factor value is equals to 5. And in the case of MnO2, the oxidation number of the manganese is +4. Out of 7 positive charges, still 4 are present, means 3 are neutralized. That means it gained how many number of electrons? 3 electrons. That's why we can write down its N factor value is equals to 3. And here, manganese oxidation state is +6. So only 1 positive charge is neutralized. That means it gained only 1 electron. So its N factor value is equals to 1. So among all these cases, we are going to discuss the redox reactions of the balancing reactions of the permanganate ion in acidic medium and how its N factor varies. So in acidic medium, MnO4 minus, acidic medium means we need to add the H plus ion. It changes to the Mn2 plus. This H plus ion always takes the oxygens to form water molecules. So here +7 is oxidation state, here +2 is oxidation state, +7 to +2, difference is only 5 and here only 1 manganese is there, that's why N factor is equals to 5 here. Here 1 manganese, total change from here to here again is equals to only 5, so its N factor value is also equals to 5. So let us see some of the reactions shown by the permanganate ion in acidic medium, how it is acting as an oxidizing agent. It converts, it oxidizes Fe2 plus into the Fe3 plus. Then how to write down the reaction? Simply add the reactant on reactant side, product on product side, again write down the same reaction here. So we can write down that MnO4 minus plus H plus plus Fe2 plus giving Mn2 plus plus H2O plus Fe3 plus. So N factor again, as I said, +7 here. Change of electrons from here to here is 5. Here also N factor is equals to 5 in terms of the manganese. Iron oxidation state +2, iron oxidation state +3. Difference is only 1. So that N factor equals to 1 here, and here also N factor is equals to 1. Let us take another reaction. How it changes stannous ion Sn2 plus into the Sn4 plus. So here again write down that MnO4 minus plus H plus Sn2 plus gives Mn2 plus H2O plus stannic ion SN4 plus. As we know that now n factor of this one already we have done that, it is equals to 5. Here plus 2 plus 4. Difference is 2, means it lost the 2 electrons. So that n factor is equals to 2. Here n factor is equals to 2. So let us take what other changes it can show. It can oxidize hydrogen sulfide into this sulfur. Then reaction again, MnO4 minus plus H plus H2S and giving the Mn2 plus H2O and sulfur. Oxidation state plus 7. So n factor is equals to 5. Here also n factor is equals to 5. Sulfur oxidation state in H2S is minus 2. And in the elemental form, sulfur oxidation state is 0. Minus 2 to 0 is difference is equals to 2. So that n factor is equals to 2. Here also n factor value is equals to 2. Let us see other reactions also. So 4, oxalate ion changes to the carbon dioxide by potassium permanganate in acidic medium. Then write down MnO4 minus plus H plus plus C2O4 2 minus giving Mn2 plus H2O plus CO2. Oxidation state of manganese is plus 7. N factor value of the manganese is equals to 5. So after examples, you will come to know repeatedly as we are saying that N factor of the manganese in acidic medium is 5. So automatically you will remember this concept. And oxidation state of the carbon in oxalate ion is plus 3. In carbon dioxide it is equals to plus 4. So N factor. Difference is only 1, but like the 2 carbons are there. Every carbon lost 1 electron, 2 carbons lost the 2 electrons, so that oxalate ion n factor equals to 2. But in terms of the carbon dioxide, difference is only 1, and here also only 1 carbon atom is there, so that n factor is equals to 1. And next, 5. So let us see the I minus oxidized to I2. So that here we can write down that MnO4 minus H plus I minus Mn2 plus H2O plus I2. So N factor, as we discussed just now, for manganese it is equals to 5 in acidic medium. Here minus 1 oxidation state, here 0. Difference is equals to only 1. So N factor equals to only 1 because only 1 iodide is present. And in case of this one, from here to here difference is 1, but like that 2 iodines are there, 2 into 1 equals to 2. So N factor for I2 is equals to 2. SO2 gets oxidized to the SO4 2 minus plus 4 oxidation state plus 6 oxidation state. MnO4 minus H plus SO2 giving Mn2 plus H2O plus SO4 2 minus. So N factor of this one is equals to 5. Here also N factor value equals to 5. Here plus 4 oxidation state plus 6 oxidation state. So N factor value difference is only 2. Here it is equals to 2. Here also only 1 sulfur atom is there. Difference equals to 2. So N factor value is also equals to 2. So like this we can calculate it. And now let us go with the potassium dichromate. K2Cr2O7, potassium dichromate. So this K2Cr2O7 on dissociation gives 2K plus ions, Cr2O7, 2 minus ion. So this is called as the dichromate ion. So this dichromate ion in acidic medium means add H plus ion, changes to the Cr3 plus and forming the water molecules. In dichromate ion, chromium oxidation state is plus 6. Plus 6 to plus 3. Difference is 3, means it gained the 3 electrons. But like that, how many chromiums are there? 2 chromiums are there. So that 2 into 3 equals to 6. So n factor value is equals to 6. But if you take this from this Cr3 plus to the dichromate ion, difference value is 3, but only 1 chromium is there. That's why its n factor value is equals to 3. And dichromate ion will show almost all the oxidizing reaction that's shown by the KMnO4, whatever the reactions we have written. All those reactions also shown by the potassium dichromate. I'll take one example, that is Fe2 plus to the Fe3 plus. So we shall take one example, Fe2 plus converting into the Fe3 plus, add this one. As I said earlier, always reactant on the reactant side and products on the product side. So that you will get the Cr2O7 2 minus plus H plus Fe2 plus giving Cr3 plus H2O plus Fe3 plus 6. So its n factor value equals to 6, and here n factor value is equals to 3, and from here to here difference value is equals to 1, so that n factor equals to 1. Here also n factor value is equals to 1. So in the similar way, you take the same examples like oxalate ion, iodide ion, whatever I had given, and sulfur dioxide to the sulfate ion, and SN2 plus stannous to the stannic. You also take the same examples, but instead of using the potassium permanganate ion, you take this half reaction and write down the reactants on reactant side, product side. Again, you practice it, so automatically you will start remembering the n factor value of the potassium dichromate or dichromate ion in acidic medium as 6. Now let us see the hydrogen peroxide. H2O2, hydrogen peroxide. So in hydrogen peroxide, why it is called as peroxide? Oxygen single bond is called as the peroxy bond. In peroxides, usually oxygen exhibits -1 oxidation state, except there is a one peroxide with fluorine where oxygen exhibit the +1 oxidation state. Except this one, in rest of all the cases, in all peroxides, oxygen exhibits the -1 oxidation state. Now, as we discussed earlier, it acts as both oxidizing agent as well as the reducing agent. So let us see how it is acting as the oxidizing agent. Oxidizing agent means it has to get reduced itself. So H2O2 changes to the H2O when it is acting as the oxidizing agent. Because here oxygen oxidation state -1, here oxygen oxidation state -2. So its oxidation number value decreased. So -1 to -2 difference is 1. Like that, 2 oxygens are there, so that n factor value equals to 2. -2 to the -1 value is only 1, so here n factor value equals to 1. Reducing agent. When it acting as reducing agent, means it gets oxidized itself. So it will convert into the H2O2, converting into the oxygen. Oxygen oxidation state -1, here 0, elemental form. So -1 to 0 difference is only 1. Like the 2 oxygens are present here, so n factor value equals to 2. And from here to here also, n factor value is equals to 2, because one difference is that 2 oxygens are present. So like that, hydrogen peroxide n factor value, when it acts as both oxidizing agent as well as reducing agent is always equals to 2. So let us see the hypo. Na2S2O3, sodium thiosulfate. So sodium thiosulfate on dissociation gives 2 Na plus ions and S2O3 2 minus M. This is called the thiosulfate ion. So this thiosulfate ion S2O3 2 minus, in reduction process, when it is acting as a reducing agent, it changes to the S4O6 2 minus. Thiosulfate ion, this is called the tetrathionate ion. Now let us see their oxidation states. This is 2 plus, this is plus 2.5. Difference for every sulfur is 0.5. Like that 2 sulfurs are there. So 2 into 0.5 equals to, N factor is equals to 1. So here difference value is equals to again 0.5. Like that 4 are there. So that N factor value is equals to 2. Let's take an example. S2O3 2 minus, on reaction with I2, it changes the I2 into the I minus, S4O6 2 minus M. As we said, plus 2, plus 2.5, 0, and this is minus 1 oxidation state. So its N factor value 0.5 difference, 2 are there, 2 into 0.5, 1. And here N factor value 0.5 difference, 4 are there, so it is equals to 2. And its N factor value equals to difference is only 1, but like that 2 are there, so it is equals to 2. And its N factor difference value is minus 1 to 0, only 1 is there, 1 iodide is there. So 1 into 1 equals to 1. And you should remember that N factor will never be 0. Means if there is nothing is there, means automatically you have to consider the N factor as always 1. Now let us see some comproportionation and disproportionation reactions. Disproportionation reactions. Definition is the reactions in which a single element undergo both oxidation and reduction called disproportionation reactions. So let us take here Cl2 changes to the Cl minus, ClO3 minus. In Cl2 chlorine oxidation state 0. Here minus 1, here plus 5. 0 to minus 1 value decreased. 0 to plus 5 value increased. Means here it is reduced as well as oxidized. Undergo both oxidation as well as reduction. So now let us see from here to here. Difference value is only 1. Like that 2 are there. So 2 into 1 equals to 2. From here to here, difference value is 5. 0 to 5. Like that, how many chlorines are there? 2 chlorines. So 2 into 5 equals to totally 10 electrons. Then how to calculate for disproportionation reactions and comproportionation reactions n factor value? So n factor value is equals to n1 into n2 divided by n1 plus n2. So n1 value, you can take any one as n1 value, any one as an n2 value. So here 2 into 10 divided by 2 plus 10, you can write down 20 by 12 is equals to 5 by 3. Is the n factor of which one? This reaction. And comproportionation reactions. Comproportionation reactions means the reactions in which an element in different oxidation states changes to the element in a single or same oxidation state. So here means it is exactly opposite to the disproportionation reactions. In disproportionation reactions, one is converting to the two different species in the different oxidation states. But in comproportionation reactions, it is not like that. S2 minus plus SO2 changes to the S. S minus 2 is a 2 minus oxidation state, here plus 4 oxidation state, here 0. From here to here, the value is decreased. And from here to here, its value is increased, from here to here value is decreased. So this is an oxidation process, this is a reduction process. So how many number of electrons are involved here? 2 electrons. Here how many number of electrons are involved? Here also, here 4 electrons are involved because difference value is equals to 4. Then total n factor value of this reaction is equals to same formula n1 into n2 divided by n1 plus n2. 4 into 2 divided by 4 plus 2, 8 by 6. So that it goes 4 times, it goes 3 times. 4 by 3 is the n factor for this calculation. So for a disproportionation as well as the comproportionation reaction, the n factor can be calculated by using this particular formula. Now let us see some decomposition reactions. Decomposition reactions. Example, let us take KClO3 changes to the KCl plus O2, 3O2. Chlorine oxidation state is plus 5. Chlorine oxidation state minus 1. Oxygen oxidation state minus 2. Oxygen oxidation state is equals to 0. So from here to here, chlorine gained 6 electrons. From here to here, every oxygen lost 2 electrons. Like that, 3 oxygens, 3 into 2 equals to, it lost 6 electrons. So here number of gained electrons is equals to number of lost electrons. Means electrons are lost and gained within the molecule from one atom to the another atom. So that's why n factor we have to consider either these 6 electrons or that 6 electrons. So complete transfer is taking place within the molecule. So n factor value is equals to 6. Similarly, PCl5 when you heat changes to the PCl3 plus Cl2. Phosphorus oxidation state plus 5, chlorine minus 1. Phosphorus oxidation state plus 3, chlorine minus 1, here it is equals to 0. So phosphorus gained 2 electrons. There are 5 chlorines. Out of 5 chlorines, 3 chlorines oxidation number no change. Only 2 chlorines oxidation number changed. See, 2 chlorines changed by 2. Means changed by only 1, like that 2 chlorines are there. So total is electrons lost is equals to 2 electrons. So again here also number of electrons gained is equals number of electrons lost. That's why n factor value in this case is equals to 2. There are some reactions where both elements participate in the either oxidation or reduction. So let us see those calculations also. We shall erase this part. So now let us see the calculations in which both elements participate in the oxidation or reduction. For example, ferrous oxalate FeC2O4 changes to the Fe3 plus carbon dioxide. Here iron oxidation state plus 2, carbon oxidation state plus 3, here carbon oxidation state plus 4. If both elements participate in the oxidation or both elements participate in the reduction, then n factor calculation formula is equals to n1 plus n2. Means here from here to here the loss of electrons are equals to 1, and from here to here loss of electrons are equals to 1. Like the 2 carbon atoms are there, 2 into 1 equals to 2. So that value, total value equals to 3 for this reaction. Similarly, FeS2 changes to the Fe2O3 plus SO2. Iron oxidation state plus 2, here it is plus 3, sulfur minus 1, here sulfur is plus 4. So from here to here iron oxidation state increased by only 1 and only 1 iron atom is present, and from here to here the value increased by 5, like the 2 are there, so 2 into 5 equals to 10 electrons. Since both participate in the oxidation process, n factor equals to n1 plus n2. So 1 plus 10 is equals to 11. 11 is the n factor here. So like this we can calculate the n factor value if the both elements participate in the oxidation or in the reduction process. Is there any general formula for this? As we can derive the one general formula using the mod equations also. For example, imagine AX, BY, CZ is the molecule that changes to the same AX, BY, CZ I am taking, but now the oxidation states are P, Q, R, S, T, U. Here you can take other values also. It is changing some other compounds. Our intention is here oxidation numbers. P value must be greater than S, Q value must be greater than the T, R value must be greater than the U, or else P value must be less than the S, Q value must be less than the T, and R value must be less than the U. See, P values, these values are higher than those values, means the process is called the reduction. And if these values are less than these values, means the process is called the oxidation. That means if all the elements are participating in the reduction or all the elements are participating in the oxidation, you can apply this formula, or else we can use another formula, that is n factor equals to number of A atoms, that is X, into P minus S, plus number of Y atoms, Q minus T, plus number of Z atoms, R minus U. So like this we can calculate the n factor values. So let us see some of the examples to understand this mod calculations, how to use this one. So we shall write down some examples. So first example here, Cr2O7 changes to the Cr2O7 2 minus changes to the Cr2O3. Chromium oxidation state plus 6, chromium oxidation state plus 3. So that this we know already, we have calculated. Now n factor value is equals to 2 chromiums are there, 6 minus 3. So here only difference value we have taken, not the signs. 6 minus 3 means 3. 3 into 2 equals to 6. N factor. So n factor of this one equals to 6. Next one. MnO4 minus changes to the MnO4 2 minus. Here plus 7, here plus 6. So n factor value equals to 1 manganese into 7 minus 6, that value is equals to 1 n factor value. So here we are calculating the n factor values only in terms of the reactant, not in terms of the product. So here 3 Mn3O4 changes to the MnO4 2 minus. Here oxidation state of manganese is 8 by 3. This is equals to plus 6. So n factor with respect to the reactant 3 manganese are there. 8 by 3 minus 6 is equals to, this is 18. 18 minus 8, 10. 10 by 3 into 3. So this value is equals to 10. Similarly, let us take the another example. Fe3O4 changes to the Fe2O3. So here also plus 8 by 3. Here oxidation state is plus 3. Then n factor of Fe3O4 equals to 3 iron are there. 3 into 8 by 3 minus 3. So this equals 9. 9 minus 8, 1. 1 by 3 into 3 is equals to only 1. Next, let us take the N3 minus changes to the NO3 minus. So here oxidation state minus 1 by 3. Here oxidation state plus 5. So n factor is equals to 3 nitrogens are there. Minus 1 by 3 minus 5 is there. This is equals to 15. 15 plus 1, 16 by 3 and equals to, this value equals to 16. Next, NH3 changes to the NO3 minus. So here oxidation state of nitrogen is minus 3. Here oxidation state is plus 5. So n factor equals to 1 nitrogen minus 3 minus 5. This is equals to 8. You should not take minus 8. It is only difference value. So that is equals to 8. So let us take the next question. So this value CH4 changes to the CO2. This is minus 4, this is plus 4. Directly this value equals to 8. So 1 into minus 4 equals to 8. Next one is C3O2 changes to the CO2. So here oxidation state plus 4 by 3, this is equals to plus 4. Then n factor equals to 3 into 4 by 3 minus 4, this is 12. 12 minus 4 equals to 8. 8 by 3 into 3 equals to 8. Next, S2O3 2 minus changes to the S4O6 2 minus. All of this we calculated. So here it is plus 2, it is plus 2.5. So here n factor value in terms of the only reactant 2 are there. So 2 minus 2.5. This equals to 0.5. 0.5 into 2 equals to 1. Next, let us take I2. Changes to the iO3 minus. So here I2 oxidation state is 0, iO3 minus. Here oxidation state value is equals to plus 5. Now let us see the calculations. N factor is equals to 2 iodines are there, difference value 0 minus 5, 5 is there. So 5 into 2 equals to 10. Let's go with the another one. So here we shall write down the some equations. iO4 minus changes to the I2O5, and next VO changes to the V2O5, next 13. NH3 changes to the N2O3, and 14 N2H4 changes to the HNO2. So like this, let us calculate the values. Here oxidation state of the iodine is plus 7. Here iodine oxidation state is plus 5. N factor value 1 iodine is there, 7 minus 5, difference equals to 2. And here VO plus 2, VO plus 5, difference value directly we can calculate, that value equals to 3. Here nitrogen minus 3, here nitrogen plus 3. So N factor value equals to 1 into minus 3, that value equals to 6. Here nitrogen value is equals to, this is plus 4, minus 4, this minus 2 each nitrogen, because there are 2 nitrogens and 4 H plus ions. So that 2x plus 4 equals to 0, 2x equals to minus 4, x equals to minus 2. And here in this case hydrogen, let us take plus 1 plus x minus 4 equals to 0, x minus 3 equals to 0, x equals to plus 3, oxidation state. So then N factor value here equals to 2 nitrogens are there, and minus 2, minus 3, 5 is there, 5 into 2 equals to totally 10. So like this we can calculate the N factor values for the various reactions using the mod method. Now let us try to see the questions, how to solve the questions using the N factor value and where we can apply this. So there is a question here. Calculate the N factor of HCl in the following reaction. So the given reaction is K2Cr2O7 plus 14 HCl gives 2 KCl plus 2 CrCl3 plus 3 Cl2 plus 7 H2O. So basically chromium oxidation state plus 6, here chromium oxidation state plus 3, N factor value equals to 6. That means chromium gained 6 electrons. Then obviously chlorine also has to lose the 6 electrons. How? There are 14 Cl minus ions here. In that, see 2 Cl minus ions and 6 means 8 Cl minus ions oxidation number, no change. But 3 into 2 chlorines, totally 6 chlorines oxidation number becomes 0, minus 1 to the 0. Then obviously it lost how many number of electrons? 6 electrons. It gained how many number of electrons? Totally 6 electrons. Means number of moles of electrons exchanged in this reaction equals to 6. But they are asking the complete HCl. How many HCls are there? 14 HCls are there. That means 6 electrons are exchanged among the 14 HCl molecules. Then 1 mole of HCl molecules, how many number of electrons are exchanged? That is what N factor. N factor is calculated for the only 1 mole of the molecule. So 1 into 6 by 14. That means here you can write down that number of moles of electrons exchanged divided by number of moles of molecules involved. So you get the N factor value. So in this way, in this case, if you simplify this further, so 2 3s and 2 7. And now let us take one more question. Calculate the N factor of HNO3 in the following reaction. So given reaction is 3 copper plus 8 HNO3 gives 3 CuNO3 taken twice plus 2 NO plus H2O. So here nitrogen oxidation state is plus 5, nitrogen oxidation state is equals to plus 2. Difference is 3. Like that, how many nitrogens are involved here? Totally 2 nitrogens oxidation state is changed. So 2 equals to totally 6 electrons. Number of moles of electrons changed equals to 6. But how many number of moles of molecules are involved? 8. So N factor equals to number of moles of electrons exchanged by number of moles of electrons taken, molecules taken. That means it is equals to 3/4. Next, let us see the another question. Find the N factor of HCl in the following reaction. So reaction is given MnO2 plus 4 HCl gives MnCl2 plus Cl2 plus 2H2O. So here chlorine oxidation state -1, here chlorine oxidation state 0. How many chlorines totally involved? 2 chlorines are involved. So that's why it means 2 electrons. Totally electrons lost equals to 2. Then N factor is equals to number of moles of electrons by number of moles of the molecules taken. That's why its value is equals to 1/2. Now let us see another question. Calculate N factor of FeCN taken 6 in the reaction FeCN taken 6 changes to the Fe3 plus CO2 plus NO3 minus is given. So here oxidation states, if you identify, this value is equals to plus 6, FeCN taken 6, 4 minus. So iron oxidation state is plus 2, carbon oxidation state plus 2, nitrogen oxidation state to be taken as -3, then here it is +4, here it is equals to +5. Iron oxidation state increased, carbon oxidation state increased, and nitrogen oxidation state also increased. So apply the mod factor. N factor equals to 1 iron, 2 minus 3, plus 6 carbons, 2 minus 4, plus 6 nitrogens, minus 3, minus 5. So this is equals to, this is value 1, this is 2 into 6 equals to 12, plus this is equals to 8 into 48, that value equals to 61 is the N factor. Now, so the question is, the weight of KMnO4 required to completely oxidize (0.25 moles of FeSO4 to Fe to SO4 taken thrice, ferrous sulfate to ferric sulfate in acidic medium, that they are asking molecular weight of KMnO4 is given, is equals to 158. So this type of the questions we can solve. For any question for this type of the titrations, you must see that using the number of gram equivalents. Number of gram equivalents equals to N into N factor. N means number of moles into N factor. So let us take the KMnO4 equivalence values equals to FeSO4. So N into N factor of KMnO4 equals to N into N factor of FeSO4. So number of moles. See, they are asking the weight. Okay, let it be number of moles. N factor of the KMnO4 in acidic medium, already we have calculated, its value is equals to 5. And number of moles of the FeSO4 to be taken here is 0.25 into ferrous sulfate converted to ferric sulfate, means Fe2 plus into Fe3 plus, N factor equals to 1. So number of moles equals to 25 into 10 power minus 2 divided by 5, it goes 5 times. So 5 into 10 power minus 2. But they asked about the weight of KMnO4. Number of moles means weight by molecular mass. So weight by molecular weight is equals to 5 into 10 power minus 2. So weight is equals to 5 into 10 power minus 2 into molecular mass 158. So we can write down this one as 5 into 158 is equals to 790 into 10 power minus 2 grams, that equals to 7.9 grams. So we can solve the questions like this. So I'll give some more questions to you. You better try on your own so that let us see whether it is helpful for you or not this class. So I'll give the question. Assuming complete ionization, same moles of same moles of which of the following compounds will require the least amount of acidified KMnO4 for complete oxidation. So the given molecules are FeC2O4, FeNO2 taken twice, FeSO4 and FeSO3. So anyhow, you'll get confused what could be the answer here. Option 3 is the answer, but solution you try it. I hope you understand this class, and I hope that it is helpful to you. If you really feel that this is helpful to you, please do share with your friends and those who are feeling difficulty in solving the questions based on the n factor, and those who want the clear picture about the n factor. I hope I had covered almost all the concepts of the n factor in this video and in this lecture. This lecture will be connected to the again Redox reactions. If you have any doubt regarding the classes of the Classroom Point, please do write to the classroompoint@gmail.com, and don't forget to subscribe the channel. Thank you.